E is a nomenclature. E is a nomenclature can be used to specify the configuration about any carbon-carbon double bond using a set of priority rules. The system is devised in 1964 by Can, Ingold, and Prelog. In E configuration, E is the German word "Antigen", which means opposite. And Z configuration, that is Z is the German word "Zusammen", which means together. In E configuration, the highest priority groups are on opposite side of the double bond, whereas in Z configuration, the highest priority groups are on same side of the double bond. Can Ingold Prelog rules. Rule 1. Each atom is assigned a priority number based on atomic number. Higher the atomic number, higher is the priority. Then rule 2. For isotopes, the one with the higher atomic masses gets the highest priority. For example, deuterium and hydrogen or protium. Deuterium has higher priority than protium. Then rule 3. If priority cannot be assigned based on atomic number or atomic mass, considering the first atom of a group, then look at the next set of atoms and continue until a priority can be assigned. If the atoms directly linked to the double bond are the same, then consider the second, third, fourth, etc. atoms and ranked until a difference is found. Rule 4. In case of double or triple bonds, atoms participating in the double or triple bond are considered to be bonded to an equivalent number of similar atoms by single bonds, that is, atoms of double and triple bonds are duplicated or triplicated. Then, to assign a Z system, first determine the groups of highest priority on each carbon. If the two highest priority groups are on the same side of the double bond, then the configuration is Z. If they are on opposite side of the double bond, then the configuration is E. Example, in this compound, this is the carbon-carbon double bond, and this carbon having two groups. First, to find out the priority of the groups. So, if this is the highest priority group and this is the lowest priority group, and for the second carbon atom, this is the highest priority and this is the low priority. If the higher priority groups are on the same side of the double bond, then the configuration is Z. In this example, the highest priority groups are on the opposite side of the double bond, then the configuration is E. And this is the another example. If the highest priority groups, that is the first to find out the highest priority groups. Here this carbon atom having bromine and iodine. Iodine gets the highest priority based on the atomic number, and this having fluorine and chlorine. So based on the atomic number, fluorine gets the highest priority. If the higher priority groups are on the same side, then the configuration is Z. And in this example, if the highest priority groups are on the opposite side, then the configuration is E. And there is another example. So here this is the carbon-carbon double bond. The atoms present in this carbon atom is fluorine and chlorine. So chlorine gets the highest priority, and for this carbon atom, iodine and bromine, iodine gets the highest priority, and the highest priority groups are on the opposite side of the double bond, then the configuration is E. In this example, the highest priority group, that is the chlorine and the iodine, are on the same side of the double bond, then the configuration is Z. Thank you.